I am delighted today to have the privilege of speaking with Arnold Reuser, formerly a geneticist at the University of Rotterdam, and we are going to be talking about a bit of the history of the discovery of enzyme replacement therapy, a little bit of a history of the process of becoming a geneticist, of what it's like, what the environment was like early on and how it has changed over time, as well as also we want to get a sense of where we are today and the type of innovations and progress that have been made, and where possibly things will go on into the future. So, Arnold, when you first started university and you were looking for a subject matter, where did you start?
It's an interesting story because it started quite spontaneously. I may have told you that I studied chemistry at the University of Amsterdam in the years 1966-1972. And I was about to graduate in 1972, the very end of 1972, when I was called by a professor from the medical faculty of Rotterdam. And as you may know, Amsterdam and Rotterdam are two cities, they want to be both the best. So I came from Amsterdam, and I got this call from this professor from Rotterdam, who I had never heard of. And he said that he had a position for a PhD student, and that he had advertised this position in a journal or whatever. And he said, "Why did you not respond?" So I said, I still have to graduate, and I wasn't yet looking for a job, so that's why I did not respond, and I didn't see any advertisement. Then he said, "Do you want to come over for an interview to Rotterdam?" So I said, "Oh, why not?" So I went to Rotterdam, and this was a very enthusiastic man. So he was promoting his institutions for about 2 hours. I didn't need to say a whole lot. And he said that the subject would be to study the cause of clinical diversity in Pompe disease. I had never heard about Pompe disease, but all in all, it was a very lively interview. And at the end, he gave me the floor and he said, "So what are your interests?" And I said, my interests are actually very broad, and this could be an interesting subject. It went like that. He said, "Okay, so let me know whether you want to have this job." And then I said, "Okay." I went back to Amsterdam and said, "I'll call you back." It really went like that. The next day, unbelievable. The next day, I went to my professor at the University of Amsterdam. And I said that I was offered this job and whether he knew this professor from Rotterdam. And he said, yes, he did. And I mentioned the subject, Pompe disease. And then he said to me, "But Arnold, why don't you stay with us? I can offer you the same position on the same subject." I was really surprised because I thought this must be, I don't know, a very important disease to investigate or whatever. I still didn't know exactly what Pompe disease was. So my decision was taken simply on different ground. I was born in Amsterdam, I studied in Amsterdam, I was 25 years, and I thought it's time to change. So I went to Rotterdam and then started to study Pompe disease. So it was not really my very first choice or whatever, but it just happened. It happened to me. And I got excited.
Yeah. Yeah, that's really quite amazing, because I think that's the way oftentimes graduate studies work. I think back to my experience, and when I finished my master's at University of Manitoba in Canada, I was talking with my supervisor one day, and he says, "So what are you going to do?" And I said, "Well, I've got two options. I could take up farming. My older brother's a farmer, and you know, if I wanted to farm, he would set me up.
Mm-hmm.
We would work together, but not exactly at the same place." And so then I said to my supervisor, I said, "Well, you know, that's one option. I don't know. What do you think my other options are?" And he says, "Well, what would you like to do?" And I said, "Well, I'd like to study at Oxford." He says, "Well, then you should apply." So I did, and applied to a number of different universities, and was accepted by all of them, and lastly Oxford came through in June, and offered me a place, and Carol and I left, you know, in end of September. We left for England, and well, that was the beginning of a whole new story. But I mean, part of my thinking too was, I've grown up in Manitoba, I've grown up in Canada, I'd like to go somewhere else. And where would I really like to study? Well, at Oxford. So I always tell my students, I say, you have to think and plan and hope to do something which everybody else isn't sure you can actually do. Because I said, if you apply, there's at least a chance of getting in. If you don't apply, and most people don't, you'll never get in.
Right, it's true. So for you too, it was it just kind of just happened, but you had at least a drive to go to Oxford, and for me it was the drive to leave Amsterdam. And then, you know, that's just the way it went.
Yeah. So these I think are stories that and experiences that I think are good to share, because they I think help to advertise a little bit how you have to take opportunities when they come to you. Now, one of the things that you know, you were working on as you were working with this professor from Rotterdam. What was the field of genetics like at that point in time?
Well, it did exist. I mean, people knew there were genes, and the DNA, of course, was invented, but many things were still unsure. A replication system, how DNA was amplified, things like that, and everything was still very, very vague, unknown, and genes, of course, were not cloned. You could not easily study genes because they weren't there. I mean, you couldn't get to them.
Right.
The technology was lacking to isolate genes and to study their nucleotide sequence, things like that. That was really nothing. So most of it was done on the level of protein. So I started studying the enzyme, acid alpha glucosidase, GAA as an abbreviation, not be able to do any genetic work. And the interesting thing was that this professor, why he was so excited, is that all these different forms of Pompe disease had been described. A classic infantile, there was a childhood form, a juvenile form, and an adult form. And he was so enthusiastic because he thought, oh, all this diversity, there must be many, many different genes involved. One for classic infantile, one for childhood, etc. That's why he was so excited. But after 2 years of research, I came to the conclusion, based on chemical work really, that there was probably only one gene with many different mutations, variants. And then he lost interest. He was so disappointed. He did not want to go on. And I got excited. So I went on, but he lost his interest. And only very, very much later, because that was in 1978, and we were able to clone the gene only in 1988, so 10 years later, because the technology didn't exist.
So, if it's the case that, like, and you're and we're talking here about the history of heredity and things of that nature, like, we know that in agriculture and in plants they've been doing this through selective breeding for generations. It's hundreds of years. We know also that in animals they've been doing this for many, many years, selectively breeding, creating new breeds of dogs and cats and what have you, etc. So what's the transition from having this background to going into something like human study?
Well, the fact was there of clinical variation. And you want to discover the real cause of this variation, because if you know the cause, you may modify the course of the disease. You know, if it is something like training, food, whatever that's causing all these different forms of Pompe disease, you direct your research into a better diet or better training or whatever. But if it is genetic, or if it is an enzyme deficiency, you go for the genetic and try to improve the genetics by gene therapy at the very last, but by enzyme therapy at the start.
Mm-hmm. Okay. Yeah. No. That makes an important point here, because it seems to me that certainly within human medicine, where the concern has always been that therapy that is a remedy to an illness is, of course, something that is very much appreciated, and whereas if you were engineering people to be stronger or of different abilities, that kind of engineering is has all kinds of ethical problems that obviously both society and the medical profession don't want to pursue.
No, it's prohibited, actually. Gene therapy is fine as long as you do not manipulate germ cells, because those manipulations, they will last forever, because they transmitted during generations.
Mm-hmm.
And for plants, that's different, and animals, but for humans it's very restricted, and I think it's a wise thing, because you should not manipulate human beings,
Right.
Not even animals, I think, but although we did.
Right. No.
We did make this transgenic rabbit producing enzyme in its milk, and but that has quite a bit of opposition.
Right.
From an ethical point of view.
Well, I think there's always been a certain segment of society that has protested against any type of experimentation with animals of any sort, and so one has to be always cautious of exactly how that is done, so that in fact you're not taking animals just out of the wild and using them experimentally. You're actually, in many cases, breeding specific animals for this type of experimentation.
And
now,
that is actually what we did, of course, by making this mouse model. And because it's not a natural model, and the transgenic rabbits, which is also not natural, of course.
Right. Now, as we've been talking about this, and I remember from our email exchange that we had earlier this week, where are things right now in the Netherlands with respect to any overlapping differences or problems or concerns between patients who have Pompe disease and having a pandemic around at the same time with all these variants coming through?
Yeah, as I wrote to you in the email, I did not hear about patients who had COVID, and later I inquired. Actually, I asked the patient, who's quite familiar with the situation in the Netherlands, and fortunately, I heard that there were no cases known of Pompe patients with a COVID-19 infection. So turns out to be okay. I think all people were vaccinated and received their boosters, but no serious problems. And this whole COVID pandemic, it's such a strange thing here. In the Netherlands, we are taking very strict measures one day, and the other day, it's they are skipped again, and everything is normal. And right now we are in lockdown. I don't know whether you heard. All shops are closed, yes, and only food shops are open. But for us, my wife and and our kids, life just continues in a quite normal way. And we are careful, but that's all.
Right.
But it's interesting, actually, because now the whole... Yeah, you go.
Oh, it's okay. I was just thinking, I think that maybe part of it may be that patients who have Pompe are already a little bit cautious and are willing to restrict themselves a little bit, perhaps partly because they realize that it's really a privilege having the enzyme replacement therapy, and it's a rather costly infusion, and fortunately in most areas that is paid for by the government. And so in that respect, I think we probably are a little bit more aware of some of the responsibilities that we as patients have regarding venturing out and just taking risks and a carefree sort of approach to life.
Yeah, I can imagine that for you it feels like that. Yeah.
like to me, it just seems like, I mean, I regulate my life by 2-week segments. You know, I have an infusion coming up every 2 weeks, and so in a sense, my calendar works in 2-week segments. You know, what am I going to do between now and the next infusion? Because those are commitments. I mean, it's like it's like written in stone. Those are things that I have committed myself to, and so, you know, when you start thinking that way, at least when I was first diagnosed with Pompe, I was actually a little bit concerned that this was going to really interrupt my life, because I was diagnosed in February of 2011, and I had just come off of a sabbatical, a half year sabbatical at the university, and so here I was thinking, you know, planning forward into the future and thinking, so what is this going to look like if in fact, you know, I get an enzyme replacement therapy. As it turned out, I didn't get my enzyme replacement therapy right away, because I asked for a general baseline testing. I wanted to have a sense of, like, where am I at right now with my physical condition? Where am I at
before you start therapy? Yeah,
before we start enzyme replacement therapy. And unfortunately, some of the people higher up in the decision-making area took that as I wasn't interested in it quite yet. And so, as it turned out, I actually waited from 2011 until 2016, which, when I was finally given
5
permission, exactly, when I was finally given permission to have enzyme replacement therapy, it was the start of my next sabbatical. And it was really interruptive. Because I was planning to spend, that was a full year sabbatical, and I was planning to spend at least 6 months in Europe. And suddenly I was told that, you know, that wasn't possible. I could be away for a maximum of 3 weeks only.
Yeah, and so have to come back. Yeah.
Yeah, and so in any case, as I say, I mean, I did get that baseline testing, so I know what my condition was like at the time when I was diagnosed, and certainly I knew that by the time I was receiving enzyme replacement therapy, it wasn't as I wasn't as healthy as I had been, though in many respects I was still doing remarkably well, and fortunately for me, it never affected my teaching career. It was never debilitating enough to require the slow down or even shortening the time in class or having fewer classes.
Yeah.
I was really fortunate in that regard.
But also, you have a strong mind, you know, and that really helps.
Well,
really
yeah,
helps. I mean, the way I've learned to know you, really, you want to set it aside and make it look like normal, but it may vary from one patient to the other.
Yeah, no, I would agree with you there. Pardon me?
This new therapy that was approved in Canada, the next enzyme, aval glucosidase alpha.
Right.
Will that be available within short?
expect that it should be available likely within 2022. Yes. So next year sometime. And likely it will, because as far as I understand the process, the federal government has in a sense approved it. Now the individual provincial governments have to decide whether they will approve it, and when they do approve it, whether they will allow for both of them. And my sense, and generally the perspective of governments, is that they will only support one of the enzyme replacement therapies. And so we will likely get the new one, and from that point forward, we will see what the impact of that will be. My own sense, just looking at or thinking and thinking about my own response to Myozyme, is that over time, I think my body has been less affected by the Myozyme than it was initially. I think your body maybe develops a certain level of immunity to it, or perhaps the Myozyme isn't no longer has quite the impact and effectiveness, and so I think having a new drug available, I think, will in fact perhaps benefit more of the Pompe patients, and some of them perhaps in slightly different ways than they were benefiting from Myozyme.
Mm-hmm. I've heard that opinion from other patients as well.
As you were working through all of these different backgrounds to the enzymes and everything else, did you, like you mentioned in your with to me, that the work began with the enzyme with enzymes rather than with the Pompe disease?
Well,
itself.
enzymes for therapy rather than genes or
right.
Working on protein work. I mean, we would call it protein work instead of DNA work. That's
okay.
the difference.
Yeah.
So the enzyme replacement therapy really started. Sorry.
Go ahead. Go ahead.
John.
I was just going to ask you to just continue on, explain a little bit about that.
Okay, so the whole idea of enzyme replacement therapy was started with the purification of enzymes. Enzymes are short, so people were isolating, purifying enzymes and just administrating it to patients. That's how it started. Genes were not important at all. You didn't have to know the gene in order to purify an enzyme and to administer to a patient. So that is how it really started. And
okay.
It continued like that because the first therapy for Gaucher's disease, which is an other lysosomal storage disorder, had nothing
right.
to do with genes, The enzyme was purified from human placentas and administered to the patients without having to produce anything by gene technology, not even knowing gene defects of patients or whatever. The genes weren't there, but the therapy was there. So it started from the protein, the enzyme side, rather than the genetic side.
So in other words, then, it was easier to discover that there was a lack of production of a particular enzyme, and then with that you began to think of how you could enhance that production.
Yeah, and that was actually the first enzyme deficiency that was discovered was GAA deficiency in Pompe disease. And that was in 1963. HERS. So a very early discovery. And then from that moment on, within 5 years' time, many different enzyme deficiencies were discovered in many different lysosomal storage diseases. And it didn't last more than 10 years that people started to purify, isolate these enzymes, or buying them from a pharmaceutical company and giving it to patients intravenously. And that went on in the years 1966 till the end of 1970. Volumes full of information about enzyme replacement therapy. And then by the end of 1970, everyone said, this is never ever going to work. And it stopped. So the whole scientific world lost belief in enzyme replacement therapy. And they started with bone marrow transplantations. And that went on for 10-year time, till the first enzyme replacement therapy again came to light for Gaucher disease. So it was a very strange period. And when Ans van der Ploeg, my first student, who is now the head of the Pompe Center in the Netherlands, she demonstrated the feasibility of enzyme replacement therapy for Pompe disease in 1988. And then we composed a very nice publication with the title Enzyme Replacement Therapy for Pompe Disease Reconsidered. And why reconsidered? Because the whole scientific field had stopped. No one believed in enzyme replacement therapy. So we had this title. And then the referee said, this grandiose title is offensive. And the paper was refused. Till we changed the title and we said, okay, if you administer enzyme to muscle cells of a Pompe patient, the glycogen will disappear. And that title was accepted. Very, very strange. But yeah, that was the thing in those days. And the genes, they came much later, 1994. So again,
so then,
more than 10 years.
How did the genes then get introduced into all of this? Like once you knew that there were all these different mutations, what did that then? Okay.
No one had ever been able to look at the genes, and they were expecting the mutations, but no one was able to look at genes. And there was a American scientist, Dr. Beutler, and he was interested in Gaucher disease, and he had constructed a DNA bank, as it is called, with little pieces of human DNA. So every gene was represented in that gene bank in little pieces. And what he did is expressing those little pieces in some way, so that on the basis of this genetic instruction, little pieces of protein would be made. And he could discover these pieces of protein with antibodies. Because everyone was able to purify the enzymes, and then we were injecting these enzymes into rabbits, and the rabbits were then producing antibodies. We would isolate the antibodies and then use them to pick up these little pieces of human protein attached to a certain piece of DNA. And when that technology became available, then all the lysosomal genes, they were cloned, one after the other. But not before 1984. All
Right.
thereafter.
Wow.
And only then, of course, people thought, okay, maybe we can use the genes to produce the proteins. But that was the next step.
Okay. So then when that all suddenly I imagine your plate suddenly looks different in front of you. Now you've got enzymes that you can and proteins that you've been working with, and now suddenly you have genes that are mixed into that. How then did you go from that stage to identifying that there were faulty genes to then discovering that there are many mutations out there?
Yeah. So once you have the gene, you can determine exactly the coding sequence. So the thing really was get the DNA from a patient and try to find the difference in sequence differences. And
right.
We started this search in 1988, and it from one patient, and it took us 2 years to find both mutations. And now we do it in 3 days with advanced technology, but it took 2 years.
Yeah.
2 years.
Yeah.
And then gradually new technology came up, and now, well, you have sequencing machines and goes automatic.
Mm-hmm. Oh, that is a really quite encouraging picture that you've shown us in this regard, because I think certainly for myself, I was aware of certain that there were faulty genes, but I always thought it had started the other way around. That it was after the genetic code became available that suddenly you start looking at that and you go, oh, okay, here's a wrong one. And I mean, now when I look at the different chromosomes, which we all can now study, and you can find out how many different diseases there are in each of the chromosomes and what is healthy. That's looking through the rearview mirror sort of thing now. We're looking back and seeing what was all possible, and we think that's happening, that just happened. And the way you're describing the picture is that there was a lot more gradual work being done with such basic things as proteins and enzymes, and then later on that gets applied to the genes that are available, and finding out that some of the genes are faulty.
Yeah, there are companies now offering screening for inherited diseases. So then they really analyze the entire genome of people. You could go for it, I could go for it, and I think you pay $600 or euros or whatever, and
right.
They will tell you whether you are the carrier of a certain disease. So they could tell
right.
me that I'm carrying probably 20 different disease genes. And of course I could also, for my partner, I could do the same.
Right.
And if we both would be unlucky and both carry of Pompe disease, then we would know for sure that 25% of our kids are at risk to have Pompe disease, even before you have kids or even before newborn screening. You can screen healthy people for carriership. So that's a totally new development in the field, which actually is on the side of prevention.
Totally, because I know, you know, when I was diagnosed and both of my parents had already died, and so that there was no sense of tracing things back. It was more a question of, you know, we could simply look around us and say, you know, are you infected and are you not infected, and in the same way. I know when I was in Rotterdam with you the second time, and my brother Don came along, we had that wonderful conversation up in the pub on the second floor for a couple of hours, just simply talking about a lot of aspects of you know, the peculiarity of diseases and how they affect, and you know, different people different ways. That was a really good time, and you know, it was again an opportunity to, you know, hear the story from you know, and some of the questions which Don had, which were different than mine, and you know, I know afterwards both of us talked a fair bit about how much fun that had been to hear the discussion about, you know, how my disease had been discovered, and then, you know, once you moved past the point of simply discovery, and that took a long period of time between Dr. Pompe and you know, the period that you began working with enzymes and proteins. But it really is quite an amazing story to think about how much that has benefited so many people.
But it took a long time, and the whole development, I mean, you're talking about a period of 50 years, and that's not only for Pompe disease, you know, it's the whole field that's moving extremely slowly, but now it's picking up speed, because now more than one company is really interested in developing therapies for Pompe disease. So there is a better chance that for better treatment in the next future. Improved enzyme replacement therapies, but also trials for gene therapy. And 10 years ago, you couldn't think about it, but now it's really developing very rapidly. So there's a lot of hope, I think. Also for the very young kids.
Yeah. Yeah, I agree with you with respect to young kids. I think that there's a lot of hope that for them, you know, sometime in their life, this they may look back at Pompe disease and be able to say that if it hasn't been conquered, it's at least been slow down to the point where it's no longer got the same impact as it currently has. And that'll be a really good day when that becomes possible. And like you say, the number of companies that are now interested in it, in providing either a therapy, gene therapy, or a drug therapy, I think is astounding, and it's a sign of better things to come.
Mm-hmm. Definitely.